Hello, my dear students, and the rest of the learners. Welcome for this presentation, which is part 8 in C++ computer programming series, in which we are going to learn about functions. My name is Memaji M, or you can simply call me Emelisoft. What is a function? A function is a module of code that you execute and control from the main function. Therefore, to make large programs manageable, programmers modularize them into subprograms, which we call functions. They can be compiled, tested separately, and reused in different programs. This modularization is characteristic of successful object-oriented software. C++ is therefore designed in a way that the programmer can write programs in different modules rather than in one long block. By breaking the program into several smaller routines, which we call functions, you can isolate problems, write correct programs that are easy to manage and maintain. For this case, each module should do only one primary task. My dear students and the rest of the learners, it is important to note that in the entire series from the first program that we covered, or from our first presentation in this series, which was part 1, we have been writing our programs in what we call the sequence structure, where we wrote a single program performing several activities in a continuous or a prose manner. Now, when the programs are very big, or when you reach a step where you write or you code programs that perform several activities, we are saying that it is important for you to know how to break down each of those activities that are being performed by the program to be condensed as a single or specific section. So that instead of having a program running into prose, or instead of having just a sequence of statements that are flowing and are being executed from the first statement all the way to the last one, you break down your large program into subprograms, or what we call subroutines, or in this case, modules. And these modules, each module, we are saying, is supposed to perform a single task or a single activity. So these modules, or these subprograms, or these routines are what we call functions. Function, just from the word function, what the function is being performed by which part of the program. So a function, we are saying, is that section, that part of the program that is performing a specific task. And these functions are linked together using the main, or in other words, while you write or you develop your code in subroutines or in routines, you ensure that you organize these routines in a sequence, in a systematic manner, so that one activity can lead to the next. For example, if you are developing a program that is supposed to add numbers, the first thing or the first activity that you do is to prompt the user for the number. It is do what we call input. So input is a function. Once the input is accepted by your program or by your processor, then the next step is to perform the required computation. That is another function. And then once the computation is performed, the reason as to why you are prompting the user to enter a certain number or values is so that you can compute and then you give the user the report or an output of the results. And therefore, displaying the results or outputting is another function. So that's what we are saying, that it is always good to break down your program into several smaller subroutines or functions so that you can be able to isolate the problem so that one problem in one of the sections does not run across the entire program, and you can be able to know or isolate the function that has the problem. And therefore, by breaking down the program into several smaller routines or functions, you are able to isolate problems. You are able to know which function is not performing the task as required and do the correction or do the debugging. So by breaking down your program, writing of the program becomes easier, and also managing and maintaining that program is easy. Each module, we are saying, should only do one primary task. So it is the number of tasks that your program is going to perform that determines how many functions that the program is going to have. When your program is composed of several functions, you invoke them within the main body of the program. In other words, whereas you write the functions outside of the main function, remember from my previous presentations, I said that the purpose of the function or the work or the role of the main function is to coordinate the flow of the program, to coordinate how activities and the sequence in which the activities are going to be performed. And therefore, whereas you break down your program into several parts, you coordinate how those parts will be executed through the main program. And we are going to see how. And therefore, that's why we are saying that when your program is composed of several functions, you invoke them within the main body of the program. So the main body is the one which contains the call statements that are supposed to invoke the execution of each of the functions. And then you organize those statements, or then you organize those statements for invoking functions is the one which determines how the program will flow and how the tasks will be executed. That is the order. And therefore, the only action that the main function takes is to control the other functions by calling them in a certain order. With a good modularized program, or with a good program that has been broken down into functions, what we're supposed to find in the main function is simply the call statements that invoke the execution of each function. So the specific activities that are performed by the functions are taken out of the main function and they are placed in their respective modules or in their respective functions. Each separate function executes its instructions and then returns to the main. Once the main function is through with the calling of functions, it returns the control to the operating system. It is advisable, therefore, that a function should not do more than one activity, and one function should not be more than one screen in length. If it is longer, you are probably doing too much in one function and should therefore be broken down into two or more functions. Simply put, never combine several activities within the same function. Let each activity be within its own function. C++ functions usually adhere to the following rules, or these are the rules that you must observe when breaking down your program into functions. Number one, every function must have a name, and this name must be clear, should be able to identify the activity that the function is performing. So the name that you give must be meaningful. If, for example, you are going to compute the area of a circle, or your function compute area, or computing area, or just area. Number two, the function names are made up and assigned by the programmer following the same rules as those which apply to naming variables. My dear students and the rest of the learners, I advise that don't begin learning C++ directly by coming to this presentation. ensure that you go back to part 1 of this series. That is part 1 in C++ computer programming, so that you can remind yourself what is required from you. And one of the things that we covered before is the rules of naming variables. And we said just a few of them. That number 1, the name of the variable or the name of your variable should be meaningful. If it is area, call it area. If it is perimeter, call it perimeter. Be clear. Number 2, we said that every name, a name should not have a space in between. And if you must join two ones, join them using underscore. And we also said that in C++, C++ is case sensitive. Therefore, if you change the case of a variable, even a single letter, the meaning changes, that variable changes. So some of those rules also apply in the naming of functions. A function can contain up to 33 characters, or in other words, the name of a function can contain up to 32 characters. They must begin with a letter, and they cannot consist, or they can consist of letters, numbers, and underscore character. This is just one of those rules that we talked about under naming of variables, which also apply to functions. All function names must have one set of parentheses immediately following them. In other words, when you write your function, under that function, once you have the function name and you have the parentheses, now these parentheses indicate that that is a function. If, for example, you want to have a function for computing area and you call it area, then you should have it as area, then followed by a pair or a set of parentheses. These are the opening parentheses and the closing parentheses, as we are going to see. And that parenthesis or that pair of parentheses should follow them, the name of the function. In fact, in C++, you identify a function with the use of parentheses. If there are parentheses there, a pair of them, at the end of its name, then that is a function. This helps you and C++ differentiate between functions and other variables. The parentheses may or may not contain something, as we are going to see. What is contained in a parenthesis is usually called a parameter or arguments based on where that statement is. If it's a declaration statement or a definition statement for a function, then you may have parameters. If it's a call statement within the main function, then we can call whatever is held inside the parentheses arguments. And we are going to see them as we proceed. The body of each function, starting immediately after the closing parenthesis of the function name, must be enclosed by braces. In other words, every function, in addition to having the function handler or the handler, which has the parentheses, we also have a pair of braces, and we begin with an opening brace and the closing brace, as we are going to see. This means a block containing one or more statements make up the body of each function. In other words, the pair of parentheses within a function are the ones that identify the set of statements or the sequence of statements that are going to be executed within the function. And therefore, those set of statements that are organized in a systematic manner in the order in which they're going to be executed within that function are enclosed between the opening and the closing parentheses, as we are going to see. The following is therefore an example of a function for calculating area of a circle and its definition. This is an example. This function is called find area. That's a very good name, a very good way of naming our function. We can tell that this function is for finding area, but we don't know it is area of what. Now, this function called find area is expected to perform or to compute area and return a value which is of type double. And we can see this function called find area is also receiving a parameter. It is receiving a certain value which is going to be placed in a temporary placeholder that is called R, and the value to be stored there is of type double. And then, just as we have said, you can see that this function is supposed to return the value, is supposed to return the value for area, the result. And therefore, this result is going to be of type double. So double find area, opening parenthesis, double R, closing parenthesis. The first double indicates that this function, after computing or performing the execution, is supposed to return a value of type double. Then find area is the name of a function. And this function, for it to be able to perform its work, is supposed to receive a value. And that value is enclosed within the pair of parentheses, the opening and closing parentheses. And that value is going to be of type double. So the double inside this parentheses, the double inside this pair of parentheses indicates the type of value that is going to be received and be stored in, let me call it temporary placeholder or memory location called R. Then we have the opening parentheses, not the opening parentheses now, but this is what we are calling embrace. This symbol within this statement. This is the opening brace. This opening brace. It is facing towards the right. So you can call it the right brace. Now, brace, just as I've said, indicates the section or indicates the starting point for the body of our function. And in this body, we have a declaration. And the declaration for what? A declaration for a memory location, temporary memory location, called area, that will only be used by the function we called find the area. So this memory location is called area. It is a local variable. The content that is going to be stored in this memory location called area will only be used within this function called find area. And once the work of find area is over, that value, that memory location will be lost. It will be done away with. So this memory location called area is going to store a value of type double. Remember, double is a value with a fractional part. Then the next statement is to compute the area. What does this function do? Or what does this statement do? Not function. What does this statement do? It picks the value in the memory location called R and multiplies it by itself, and then multiplies the result gotten by the value of the memory location called the pi. And then the results will be assigned in the memory location that we have set aside, that is local variable called area. Now, if you look at this function, we don't know the value of pi. Where is pi? We have R, but we don't have pi here. It simply means that if we are able to access, if the function called find area is able to access a value that is not stored within this function, it means that that value is a global value. It is the value we are looking for is stored in what we are calling global variable. And therefore pi is a global variable, meaning the content of that memory location called the pi is accessible from anywhere by any function within the program. Once we have computed, this statement here means, return area means, pick the value in the memory location called area pick that value, and return it to the caller. Return it to the caller. And who is the caller? The main function. Simply, is the value now that we're supposed to return. The value in memory location called area is going to be picked and will be returned by the function called find area. So find area in the main function represents the value that has been computed or the result of computing area. So the function will return the value and its work will end. This is what we are calling the closing brace. Or you can call it left brace. Why? Because it is facing on the left. Good. Now, a function provides a convenient way of packaging a computational recipe so that it can be used as often as required. In other words, you can call a function as many times as you want within the main program. A function definition consists of two parts, the interface and the body. The interface of a function, also called its prototype, specifies how it may be used. It consists of three entities. One, the function name. This is simply a unique identifier, and we have said every function has a name, and every function should have a unique name. So don't use the same name for the same functions within the same program. Then we have what we call the function parameters, also called the function signature. This is a set of 0 or more typed identifiers used for passing values to and from the function. So we usually have a function, that's function name, followed by parameters. And remember, parameters may be optional. It will depend with whether the function that is going to be executed will need a value to be passed to it or to be received by it. If a function is to receive the results from another function, then that function should have parameters. Then we have what we call the function return type, just as you have seen. The function return type specifies the type of values that the function returns. Like in our case, we have seen that our function called find area is going to return a value of type double. A function which returns nothing should have the return type void. In other words, the return statement is usually included within a function that is supposed to return a value. But if a function is only meant to perform a certain activity, like accept input and not pass them anywhere, or just display results that it has received from another function, in that case, because this function is not returning any value, then we can have the return type void, or we can do away with the return statement. Therefore, to prototype a function is to inform the compiler of the function's parameter types and its return value if necessary. To prototype a function, copy the function's definition line to the top of your program. That is, immediately before or after the hash include outstream line. In other words, my dear students and the rest of the learners, it is good practice that you don't define a function before main. And therefore, if your function or if your program is to be making use of functions that are going to be coded outside of the main, and you want to define them after the main, it is important that you make the compiler be aware about the existence of functions that is going to be making use of later. And therefore, in this case, it is good, first of all, you prototype the functions that are going to have in your program before main. And then you define them after main. Therefore, to prototype a function, in other words, to make the compiler be aware about the existence of the functions that is going to be making use of that have been defined after the main. It is good always to prototype. Prototyping is simply making the function, making the compiler to be aware about the existence of a function. And when you prototype your functions, to prototype a function, copy the function's definition line to the top of your program immediately before or after #include outstream line. Then place a semicolon at the end of the function definition line, and you have the prototype. We are going to see how that is done. The definition line, which we usually call the function's first line, contains the return type, the function name, and the type of each argument, as the function prototype serves as a model of the function that follows. In other words, when the compiler reads the prototype, which in this sense is the definition line for a function, but containing a semicolon, the compiler is able to know what the function is going to do. And that's what I'm calling model of the function that will follow main. If a function is not returning any value, still prototype it using the reserved word void under the return type and under the parameters. All functions must match their prototypes. In other words, the function's definition or the function's header must match its prototype. The following are some examples of void and non-void function prototypes. That's what we are saying. This is a function called input name. It means this function is for prompting the user to enter his or her name. This function is not expected to return any value. And therefore, its work is just to accept the name. And that's why it has the return type void. It is returning nothing. So we avoid input name as the name of the function. And this function is not receiving any values. And therefore, it has no parameters. That's why the tail parenthesis is empty. And because this is a prototype, we terminate it with a semicolon. When the compiler encounters this statement, this prototype for a function, in fact, it will know that there is a function whose header or definition is void input name somewhere. And therefore, it will go to look for it when the time will be ripe for it to execute it. Now, this is a void function because it is not returning any value. So it is void to the calling function. So the calling function will not receive any value after this function has been executed. We have another example, double find the area, double R. Now, what does this prototype do? This is a function prototype. It is telling the compiler that we have a function called find the area defined after main. And this function called find the area is going to be receiving a value of type double. That value will be passed to it by the main function. And after the computation, this function called find area will return a value which will be of type double. So this is a non-void function. Why is it non-void? It is returning a value. So functions that do not return any value to the calling function are said to be void functions. While the functions that return values to the caller are called non-void functions. So we have two types of functions in C++. The first type is the void type, and the second type is the non-void type. So the non-void functions return a value or values. It returns a value to the calling function. And in this case, our function called area is going to return a value of type double. Once you prototype a function, you then proceed to define the function after the main function. Kindly note, my dear students and the rest of the learners, if you have to define a function after the main, you must prototype each of those functions. But if you do not want to prototype, but you want to define your functions before main, that is okay, but it is bad practice. Good programming practice. Don't define functions before main. Prototype a function, work with the main function, and then define the functions that you have prototyped right immediately after the main function, after the closing brace for the main function. So you prototype or declare a function before main function, but after hash include outstream. In other words, it is good practice to prototype your functions between the hash include outstream and before main. So you prototype or declare a function before main function, but after hash include outstream line, and then you define the same function immediately after the closing brace of the main function. The following are some examples of void and non-void functions definitions for the function prototypes that I have already discussed. The first one is the function called input name. This name is very clear. It's a function with a very nice name. By reading this function, the name of this function, you can tell what this function is doing. This function is supposed to accept the name. It's not supposed to return anything. So this is a void function header. My dear students and the rest of the learners, kindly note the difference between function prototyping and function definition. In the function definition, we don't have a semicolon after the pair of parentheses. Like in this case, void input name, then parentheses. We don't have a semicolon. We only had exact duplicate of this heading, this statement, and the prototype, but with a semicolon. Then we have the opening brace. Then in this function, we have one variable, or we have one variable called name, but this name is composed of maximum of 20 characters. So we are declaring a memory location in which to store a name that does not exceed 20 characters in length. So we call it an array of characters. So this is the memory location in which our name will be stored. Our name will be stored and the memory location called name. And then this statement is prompting the user to enter the name. Then we read the name. And then we write out or display on the screen, welcome. Whoever had been entered, if the user had keyed in meme, it will read welcome meme. And then move the cursor to the next new line. Write out a new blank line. That's what the escape sequence character that is following the name here means. The last \n. We read it as a single character. It's a new line operator. Then we have the closing brace. That's the end of the function. As you can see, we don't have any return statement in this function because this function is not returning any value, and that's why its name, its return value is void because it's not returning any value. Then we have the next function definition, which is called find area. This function is for computing the area. It is receiving a value, one value called R, or being stored in memory location called R. And this function is supposed to return a value of type double. We have the opening brace there to indicate the body of our function, and the first statement in the body is declaration of a local variable, which is called area, which is supposed to hold the value that has a fractional part. That's why we are calling it double. And then this statement is for computing the area of the circle. In fact, this is a circle. We are picking the value in the memory location recorded R, multiplying by itself, then multiply the results with the value of memory location recorded pi, assign the results in the memory location recorded area, and then we return the area. This statement means pick the content of memory location recorded area and return it to the calling function as find area. So the value in the memory location recorded area is of type double, just as you can see here. And our function is returning. Our function is returning a value of type double. The body of the function contains the computational steps or statements that comprise the function. Using a function involves calling it. A function call consists of the function name followed by the call operator brackets, inside which 0 or more comma separated arguments appear. In other words, within the call, if you are calling a function and that function needs to receive a value, you need to pass the value that that function will use through the call statement. Therefore, if a function is going to be receiving any value, the calling statement should also call while giving that function what it requires. In that case, if a function will require some values, those values should be passed to it by the calling function, which is the main, and in this case, the memory locations that contain the value that you want to pass will have to be enclosed in this pair of parentheses. The number of arguments should match the number of function parameters. So if a function is going to receive one parameter, then you need to pass to it one argument. If a function is going to receive two parameters, you need to pass to it two arguments. If a function is going to be requiring three values, that is three parameters, you need to pass to it three values, or what we are calling three arguments, etc. Each argument is an expression whose type should match the type of the corresponding parameter in the function interface. An example of a function call is sum, passing to sum three values. The value found in memory location code A, value found in memory location code B, and value in memory location code C. Now, my dear students and the rest of the learners, this is the statement that will be found in the main function. It simply means that we have another function called, or we have a function somewhere called sum, which is supposed to compute the sum. And that function required to be passed to it three values. The value in memory location called A, value in memory location called B, and value in memory location called C. So that is one call statement. The second call statement is sum without anything enclosed in the pair of parentheses. My dear students and the rest of the learners, the values that have been enclosed in the pair of parentheses, which are A, B, and C, for this call statement for the function called sum, those are what we are calling arguments. They are called arguments if they are in the calling statement. Invoking statement. This statement invokes the function called sum, and it is passing to it three values, A, B, C. So those are three arguments. And the receiving function called sum must have three parameters or three placeholders. The first placeholder to receive the value in memory location called A. Second one to receive value in memory location called B. And the third one to receive the value in memory location called C. But if a function is not going to be receiving any value, you just invoke it without passing to it any arguments. And in that case, this function here called sum, the sum which has only the pair of parentheses with nothing inside, that function invokes a set of activities, or this statement invokes the function called sum, but that function is not going to be in int of receiving any value. So nothing is being passed to it. When a function call is executed, like sum, opening parenthesis, A, B, C, closing parenthesis, a semicolon, the arguments are first evaluated. And in this case, our arguments are A, B, C. And their resulting values are assigned to the corresponding parameters. Remember, every argument must match with its parameter in the receiving function. So if the first argument is real, is double, the parameter to receive it must be double. If B is integer, the receiving parameter should be integer. If C is Boolean, the receiving parameter should be Boolean. In other words, the order of arguments in the calling statement or invoking statement must match with the order of parameters in the receiving function. So the function body is then executed. Finally, the function returns value, if any, to the caller. Since a call to a function whose return type is non-void yields a return value, the call is an expression and may be used in other expressions. By contrast, a call to a function whose return type is void is a statement. The following are therefore some examples of call statements for the prototyped and defined functions that we are going to look at. We have this call statement, input name. So there's a call statement for invoking the function called input name. That function is not supposed to return any value to the caller, and the call statement or the main function is not passing to it any value. That's where the parameters or the parentheses are empty. This is therefore a void function call statement without any actual parameter and does not send any value back. So within our main function, we have the statement for calling, invoking the function called input name, and we write it like that within the main function. So this is a call statement. It is invoking the function called input name, which is not receiving any value from the main function, and it's not expected to return back any value to the main function. The next function or the next call statement, our next call statement to invoke our function that we're going to talk about called find area is this one here. Now look at this statement. What does this statement mean? This is what this call statement means. This call statement is invoking a function called find area and passing to that function one parameter called radius, meaning that already in the main function, we have a memory location that has been set aside and it is holding a value. And that memory location is called radius. So this statement is picking the value in the memory location within the main function called radius and sending that value to the function called find area. So outside the main function, we have our function called find area. Now that find area function is going to receive one parameter. And that one parameter, or is going to have one parameter to receive one value that has been passed to it. So that parameter, regardless of its name, will be receiving the value in the memory location called radius. The value for radius that is being passed to it. Note, the name of an argument in the call statement, the name of that argument may not be the same one as the name in the receiving function's parameter. What must match is the type of data that is being received. So in the receiving function, the function called find the area, wherever it is, or wherever it is defined, what it will have is it will have a parameter, regardless of the name of that parameter, but that parameter will have to match with the type of that parameter will have to match with the type of the argument being passed to it. So we are invoking the function called find area and passing to it one argument or a value called radius. So it is going to receive it. Once it receives our value called radius, it will compute or execute or perform various activities to compute area of the circle. After computing the area, it is supposed to return it back to our call statement here. So the control, once the function called find the area has been invoked and it has received the value called radius, it is going to perform the computation. After the return statement for that function is invoked, that function will return a value, and that value will be assigned to the memory location called area. So this call statement means execute the function called find the area that is going to receive the value called radius. And then the value that will be returned by that function be assigned or stored in the memory location within the main function called area. So this is a non-void function call that invokes a function, passes value of radius to 8 for argument, then receives the result and assigns that result to the variable that we are calling area. In general, a function should always be declared before it is used. A function declaration simply consists of the function prototype, which specifies the function name, parameter types, and return type. Because a function definition contains a prototype, it also serves as a declaration. Therefore, if the definition of a function appears before its use, no additional declaration is needed, but we have said that that's a poor programming technique. Now, use of a function prototype is nevertheless encouraged for all circumstances. Collecting these in a separate header file enables other programmers to quickly access the functions without having to read their entire definition. The following are thus two examples to illustrate how to declare a function and non-void functions. That is how to declare void and non-void functions in a C++ program, which is called function declaration. So this is one statement. Double find Perry, double radius. And we have said that this function called, or this statement is for invoking a function called find area, or not find area, but for invoking a function called find peri. It is for finding perimeter. This function is receiving one value of type double. And then it is performing a computation and returning the results to the calling statement. That's why we have double for the return type. So return type is double. Find peri is the name of the function. Double radius is the parameter. So this statement simply indicates or means that it is receiving a parameter and it is supposed to return a value. It is receiving a parameter called radius and it is returning a value called find peri. The return value is always the name of the function. Then we have this other one here. This is a statement. Now this statement is for invoking a function called results. Now this function called results has a return type void. So void results, meaning the function called results is not expected to return any value, but it is receiving how many parameters, how many values? It is receiving 2 parameters. Now these 2 parameters are area and perimeter, both of them of type double. In addition, a variable scope is important when handling functions because it determines which functions recognize certain values or variables. If a function recognizes a variable, the variable is visible to the function. Therefore, variable scope protects variables in one function from other functions that might override them. If a function doesn't need access to a variable, that function shouldn't be able to see or change the variable. In fact, everything defined at the program scope level, that is, outside the functions and the classes, is seen to have a global scope. In other words, my dear students and the rest of the learners, when we are setting memory locations aside, when we are declaring our variables, we should be very specific. We must know which memory locations or variables should be accessed by a specific function only, and which one should be accessed by all the functions within the program. If you want your functions, all your functions to access the value of a memory location, then you make that memory location to have a global scope. That is, be accessible anywhere and everywhere within the program by every function. And therefore, in that case, you define or you declare that variable outside of the main and outside of the functions. But if you want a variable to be only used within a certain function and to be known by that function only, then we need to define or to declare, that variable within the body of the specific function that will be using it. So it will have what we call local scope. So global variables are those variables that are declared and defined outside the functions. Global scope means that the entire program knows that a variable exists and they can be able to access it and it can change its contents. Therefore, global variables can be dangerous because parts of the program can inadvertently change a variable that shouldn't be the case or that shouldn't be changed. It is therefore important to make every variable in a program local to its function and then be shared across functions by passing the results to those functions that need to use them. Local variables are thus the variables that are useful only within a function. They are only known by the function in which they are defined. Those local variables, or these local variables, can be seen and changed only from within the function in which they are defined. The content of a local variable is thus protected because it cannot be changed, used, or erased by any other function without passing it. Local variables are variables with a local scope. Or local variables are variables with a local scope, and they are the ones that are declared and defined inside a function within the body of the function. The following are some examples of variables with local scope, that is, local variables for the functions that we have already prototyped and defined. The variable by the name in the following function is local to the function called input name, or the variable called area is local to the function called find area in the following two examples. So in this function, so we have our function called input name here. Now this function, if you look at it, we have this variable here. This variable is of type char, is an array of char. Now this variable is declared inside the function called input name. It is within the body of the function called name. And therefore, it can only be used within this function between the opening and the closing brace here. So this function called name is only known by the function or this variable called name is only known by the function called input name because it has been declared inside the function called input name. And therefore, because it's only this function called input name that knows or is aware of this variable called name, the variable called name has local scope. It's only known by the function called input name. And then we have this other function here. Now this function is called find area. Inside this function, we have this variable here. It's called area of type double. Now this function called area is only known and is only going to be used within this function. But because its value is important, the results are important, you can see we are passing the value back to the caller through the function called find area. And therefore, the double area, this variable called area in this function, this one, is a local variable. It is only used by the function called find area. It has a scope only within the function called find area, and it is only known by the function called find area. But because we're interested with the results of this area circle, then we have to pass the value back to the caller, who can then delegate or reassign the value to any other function that will need it by passing to it the value in form of parameter or arguments. Therefore, if you have a local variable that you want to use in two or more functions, you can always pass that variable from one function to another. And that is the work of passing variables. You pass variables. You pass variables from one function to the main function and from the main function to another function, so that those other functions can use them within their scope. When you pass a local variable from one function to another, you pass an argument from the first function to the next. You can pass more than one argument at the same time using the same call statement. When a function passes an argument to another function, it is said to be calling function, or it is said to be the calling function, or the function that receives the argument. Called a parameter when it is received is called the receiving function. To pass a local variable from one function to another, you must place the local variable in parentheses in both the calling and the receiving functions, just as we have seen and as we are going to see. The following are some examples on how to pass some values to a function from the main function using call statements and how the parameters are received by the function. So, just as we have discussed, my first example is this statement here. Now, this statement in borrowed is a call statement that is passing one argument, which is radius, to a function called find area. Now, after the function called find area has completed its execution, it is going to return a value. Remember, the name of the function represents the value to be returned. So the value that will be returned by the function called find area will be called find area. So that value for find area, that value that that function will return is going to be assigned to the variable called area. And therefore, this is a call statement that is passing one argument, that is radius, to a function called find area. After the function is done, the caller receives a value that is returned to it by the function, by the called function. And that value is the one which is being assigned to the memory location called find area. My next example is double find area with one parameter or one argument. This function, this is a function, or this is an invoking statement for a function called find area that is receiving a parameter of type double that is called radius, sent to it by the calling function. After the find area function is done, it returns a value. It returns a value to the caller. And in this case, this function is going to return a value of type double. So, these two examples are clear illustrations of how to pass values. Now, it's important also to note something here, my dear students and the rest of the learners. Note that this first statement, this one, is a call statement for passing a value to a function. And the function is called find area. And this is the function. This is the function which is receiving the value. As you can see, let me demonstrate to you. As you can see here, this is a call statement. This call statement is passing one argument called radius to a function called what? A function called find the area. Now, this value, this argument, will be directly placed in the memory location called radius there. I repeat again, because we have said that the call statement, the argument being passed should match with the receiving function's parameter. This is what we are saying. This is a call statement. The first statement. This one is a call statement. It is invoking a function called area. Which function is that? This one. So it is invoking a function called find area. You can see the name of the function in my calling statement is completely the same one as the name of the function, the same function where we have the prototype. Then we are passing, this call statement is passing one value, is passing an argument called radius to the function called find area. So this is what will happen. The value in the memory location called radius, the one which is being passed, will be taken directly all the way to where the function called find the area is, and the value will be dropped in the parameter called R. You can see, just as I've said, that whereas in the calling statement, our argument is called radius. In the receiving function's prototype, it is called R, but the type is double, meaning that the value which is going to be received by this parameter here called R must be of type double. So the value which is being passed by the caller as radius must be of type double. And then once the function called find area has completed its process of execution, it is supposed to return the result back to the caller through the call statement. So after the function called find area is done and it has gotten a value which is of type double, that value will be sent back to the calling function, and then it will be assigned or stored in the memory location called area. So the call statement's arguments must always match with the parameters for the receiving function. Very important to remember. Another example is this call statement here. Now, this call statement is passing two actual parameters to a function. And which is the name of that function? The name of that function is results. Now, this is how our function's prototype is going to look. As you can see, here we have, this is a call statement within the main function. This is the call statement. This statement is invoking the function called results. It's activating the function called results. Now, this function called results is being passed to it two arguments or two values, which is sometimes called the action parameters. The action parameters. Another name for arguments is actual parameters. And then those other parameters within the receiving function, those ones we can call them the formal parameters. So when this function called results is invoked, you can see this is the name of the function within our call statement, and it is matching completely with the name or with the same name under the function prototype or definition. Now, when this main function is invoking the function called results, it is passing to it two arguments. The first argument is called area. So the value of memory location called area is being passed to the first parameter there. Then the second value in the memory location called perimeter is being picked and being passed over to the parameter called perimeter. So you can see they must match. The order of arguments in the call statement must match with the order of parameters in the receiving function or the function which is being invoked. Then, once the function called results has received what it has received, you can see it is not passing any results back. It's not sending anything back to the caller. And that's why this call statement does not have any equal sign and with the results being stored anywhere. Good. So my dear students and the rest of the learners, kind of note how you call a function, how you invoke a function. If you're invoking a function that's supposed to receive some values, pass those values to it. If there are more than one, ensure that those values and their types are organized in the same order in which the parameters for the receiving function are organized. As function is defined when the C++ compiler reads the first statement in the function that describes the name, and when it reads any variables that might have been passed to that function as well. It is always good and safe to pass parameters by value because it's just a copy of the variable that is passed, and any changes made to the value received does not affect the original value. Remember, there are two ways of passing parameters. You can pass by value or pass by reference. If you pass by reference, you are sending or passing a memory location that is containing a value to another function. So any change that will be made by that other function will affect the value for that memory location. So it's always good to pass a copy of what is contained in the memory location to another function so that you reserve the original value without operation. A function that is called by another function but does not return any value is usually called a subroutine in C++. Therefore, if you want to return a value from a function to its calling function, put the return value after the return statement just as you have seen. And the syntax for the return statement is always as follows. Return, you enclose the value that you are returning to the caller. For example, if a function is done with the computing area of a circle and you want to pass that area back to the calling function, then you enclose the value under pair of parentheses after the reserved one return. So you have it as return area. You enclose area in parentheses and you terminate it with a semicolon because area will be the return value. The following is therefore a sample program demonstrating how to implement void and non-void functions in C++ in terms of function prototyping, functions definition, parameter passing, variable scopes, function call and arguments. This program is for computing the area and perimeter of a circle. Let's see. So this is a comment statement. Program implementing functions, prototypes, parameter passing, variable scopes in C++. It is for welcoming the user, request for areas, and calculate the area and perimeter of a circle. Then our program's name is function circle area peri. Simply, as you can see, this name tells us that these are functions or use of functions for computing area and perimeter of a circle. So we have our first statement there. I believe you know what it stands for. Hash include outstream. This statement we say is always used in situations where you are going to be making use of the input and output devices. And then we have using namespace standard. I hope you know the work of the standard library here. And then this is now a global variable. My dear students and the rest of the learners, note, you can see that this is a global variable with a global scope. We are declaring a memory location called pi. We are declaring a memory location, setting as it assigned, giving it the name pi, which is supposed to hold the value of type double. And that value is not supposed to be changing const. And the value we are assigning into it is 3.142. You can see this declaration statement is outside of the functions. It is outside of the main function. So it has global scope. Its content will be accessed from anywhere within our program. Then next, just as I said, it's always good to prototype your functions. So our functions prototypes are, we have void input name. These are the ones that I've already explained. The second one is double input radius. Then it's good to remind you, we have seen that these ones are, the first one is a void function. It's not going to return any value. The second one is input radius. It is going to return a value, but these two functions, input name and input radius, are not receiving any parameter. Then we have our next prototype, which is double find peri, double radius. So this function is called find peri. It is receiving a value. So it has one parameter called radius, and it's expected to send back the caller the results, which will be of type double. And then we have another function called find area. This one is receiving one value, which is of type double. I'm supposed to return a value to the caller of type double. Now, this is what we call function prototypes. Function prototypes. You can even call it function declaration. You are informing the compiler that you are going to be making use of these functions. So the definitions, the real set of statements that each of these functions will be required to do will appear after the definition. That is after the main function. So always prototype your functions, then code them, define them at the end of the main. And we also have this fourth one, which is for a function called results. This one is not going to return any value. So it is of type void, but it is receiving two parameters. One, perimeter, the other one, area, and both of them are of type double. So we expect to see the definitions for this at the end of, after the main. Then we go to the main function. We have said the work of the main function is simply to coordinate the execution of our functions. So within the main, we are setting three memory locations aside. One called perimeter, the other one called area, the other one called radius. And all of them are of type double. And because they have values, or they are known just within the main function, we call them local variables. They are local main. And then we now call the functions. So the first is a call statement without any actual parameter. It is for invoking the function called input name. Then the next one, this is a call statement which receives value of radius from a function and assigns it to a variable. In other words, just as I've said, when this statement is invoked, it is going to receive, this one is receiving a value from the function called input radius, and that value is being assigned to our local variable called radius. From there, we have this function or this call statement here. Now, this call statement is picking the value in the memory location called radius. And note, this value has been received from the function called input radius. So the input has been turned through the function called input radius. Then it has been returned to the main, and it has been stored in memory location called area. Now, this statement is picking that value in the memory location called radius and sending it to the function called find peri. So it is invoking the function called find peri and passing to it the value of memory location called radius. After this function is done with performing its activity, it is going to return a value, and that value is being assigned into memory location called perimeter. So this call statement passes an argument called radius to the function called find peri, then receives the results as find peri, and assigns those results the variable called perimeter. The next is a call statement, which passes value of radius to a function, then receives the results from that function and assigns them to a variable or the area. So this function, this call statement that is invoking the function called find the area, and it passes that function one variable, one argument, the memory or the value of the memory location called radius. After the function is done, the value is returned as find peri, and that value is assigned the memory location called area. Then this call statement that is picking the value of memory location called the area and the value in the memory location called perimeter. And this statement is passing the two values to the function called results. So this is a call statement which passes two actual parameters, area and perimeter, to the function called results. And our function main ends its activities and returns the control back to the operating system, and that indicates the end of our program. Now, after the main, we are now going to see the definitions for our functions. So the first is, now what we are doing is to define the functions. So the first one is void function without parameters. It is accepting and displaying the username. So this is now the full function. So this, the first statement here, we call it input or function header. If you put a semicolon at the end, it becomes the function prototype. But for definitions, we don't have the semicolon because we are defining the function here. We are telling what this function what's supposed to do. So I have already explained what this function does, and its work is simply to prompt the user to enter his or her name, store that name in memory location called name, and then welcome the person whose name has been entered. Welcome Julius, welcome Jane, etc. So these are functions for welcoming the user. Prompting the user for the name and welcoming him or her by his name. The next function is for inputting radius, just as we have said. So this function is not receiving, in fact, this function is not receiving any value from anywhere. So it is prompting the user for radius. And the value of radius is stored in memory location called R, which is local. And then this function is sending back the value of radius to the caller as double. Then we have this next function, which receives one parameter and makes use of one global variable called pi. So this function, this is a function enter, and this is our function. Look at it, very small. Now this function is called find peri. It is receiving the value of radius. So it is receiving one value for radius. Then it is multiplying the value received with the value in memory location called the pi, and then the results are multiplied by 2. And that result is returned. Now, it's important for you, my dear students, and the rest of the learners to note that we could do this statement in another way. We would have a local variable within this function called find peri that would store the results of the perimeter of the computation. So we would have a variable, for example, called the perimeter, and then you would have it as perimeter, or you would have it as radius times pi times 2, then assignment operator, perimeter, and then you could have the return statement as return perimeter. So you can, under the return part, as you can see, sometimes there may be no need to store, to hold a value within the function. You can just have the function performing its computation and returning the value directly, the result of the expression. So as you can see, in this case, What we enclose in the parentheses here is the expression. So we are returning the value of the expression as double. Then the next function is receiving one parameter called radius or r. Then computes the area. Note, this is the function. This function is receiving the value sent to it as r, the value of r. That value is stored in a placeholder called r. Then the value received is multiplied by itself, and the value of memory location called pi, and the results are stored in the local variable memory called area. And then we are returning the area. The function find the area is returning area, the results of the computation, as double to the caller. Then we have this other function here. This function is receiving and displaying area and perimeter. So it is receiving the value of area. It is receiving perimeter. So it is receiving two. It has two parameters. One, area, the other one, perimeter. It is receiving the value for perimeter and the value for area. And then what is it doing? It is displaying the values received. It is receiving the values received just as they are. That's why it is outputting area and perimeter. So this function, its work is purely to receive the values of area and perimeter and display them on the screen, as you can see. Now, before we end the program, let's see how, or before we end this presentation, let's see how this program can be coded in C++. Already, we have coded our program. This is our full program. So our full program begins here. This is our full program. So we have the hash include outstream. Then here are the prototypes. After the prototypes, we have the main function. And the main function's work is purely to invoke various functions. Then after the main function, we now define our functions. So these are our functions that we have defined. So we define our functions. Let's now see how we can put this together. Let's see how the results will look like. So my dear students and the rest of the learners, I advise you that you code this program as it is. Code this program, copy it as it is in your exercise books or using an editor like Microsoft Word. Copy this program as it is. Beginning with the comments, the hash include, using namespace, declaring global variables that you need. Then we have the prototypes here for our functions that are defined after the main. Once you finish the prototyping, the next thing that follows is you code the main. And in the main, it's always good to ensure you have only the invoke statements, the core statements for the functions that you have. Now note, when the compiler encounters a core statement, like input name, it goes first of all to its prototype. It goes to its prototype, like this one. So if the function, if the main function, if the compiler within the main function encounters this statement, input name, the core statement, this is a core statement which is invoking the function called input name. It will go to the prototype, find out whether that function exists. Once it finds it, it then goes to find where that function has been defined and performs the task there. And then once that function is done, the control is taken back to the caller, the next core statement. This is the next core statement in the order. So when the function called input radius is encountered, or not the function, but when the call statement, this call statement is encountered, it is invoking the function called input radius, and it's not passing to it any parameter and or any argument. So in that case, when this statement is encountered, the compiler will look for the function called input radius. And note this, because of the assignment operator, it means it must be returning a value. So it will go and find out, do I have a prototype for a function called input radius? Is it returning a value? Yes, it's supposed to return a value called double or of type double. Then now it goes after the main to look for that function. And here is our function for inputting radius. So it will perform the activities here. Once the return statement is encountered, this function will return the value double to the caller. So it will go back to the main function, or not main, but yeah, it will go back to the main function. And now, because it is carrying with it a value, input radius is carrying with it a value, that value will be stored in memory location called radius. Once that is done, the compiler will move on to the next statement. It will invoke the function called find penny, and it will pass to it a value called radius. And the compiler is aware that before it goes there, the value it will pick is supposed to come under a sign. So it means the function called find penny is expected to return a value. So it will go after or before main and find out whether there's a function called find penny. It is already passing a value to it, so it will check for the parameter. Yes, a parameter, provision of parameter is there, and the function is supposed to return a value of type double. Then after the main, it will go to that function called find penny and perform the activities there. Then return the value back to the caller here. And that value will be stored in memory location called perimeter. And that function will be done. Then the compiler or the control will be taken to the next statement. It will invoke the function called find area, and it's going to pick the value in memory location called radius and pass it to the function called find area. By the virtue of the assignment operator here, the compiler will be aware that the function called find area is expected to return a value. So it will go and look for the parameter for the prototype. So this is the prototype of finding area. You see, the function is there. It is going to receive one parameter and is supposed to return a value of type double. Then the compiler will go after the main and look for that function for finding area. Then once it is done, the return statement will return a value, and that value, which is of type double, will be assigned now to the memory location called area. Then the control will be taken to the next statement, which is the next call statement. The call statement here is for a function called results. So the compiler will pick the value in memory location called area and the value in memory location called perimeter. It will carry them just as they are in that order and go and look for the function called results. Is results prototyped? Yes, here it is. And it has how many provisions or parameters? 2. It has the area and the perimeter both of type double. So the values that has been brought are supposed to be directly placed in the placeholder for area and perimeter. And this function is called result, so it's not expected to return any value. So the compiler will look for that function's definition. Where is that function's definition? So it will move all the way where the function is. Here's the function. So the value which was being carried from the main function for area will be dropped in the memory location called area or placeholder called area, and the other value will be dropped in the parameter or in the placeholder called perimeter. And then it will output the values. And once that is done, the control will be taken back to the main function. So where will it go? It is when done with results. So the next statement is return 0. So which means take the control back to the operating system and end the program. Now with that in mind, let's pick our program as it is, just as it is. Let's now pick it, and then I'm going to paste it directly as it is in my editor. And then we see how the results will look like. So let's go to C++. Just open your C++ program. Follow the steps for starting a new C++ program. Now, once you have done that, you are supposed to write that program as it is here on the editor, or you can just copy and paste your program here if you have typed it in another editor. But if you have not typed in another editor, just code it directly. So in my case, I will copy this program as it is and paste it here in my editor as follows. So my dear students and the rest of the learners, this, I want to show you my program. This is our program. Let me. So this is the program that I've already explained. So let me copy my program. Let me just copy my program just as it is, just as I've explained. So you copy your program, then go to your editor in C++, and then you just paste your program there. So I have copied and pasted my program just as it is. However, note, you can type this program directly on your editor. It's just for the sake of simplifying the amount of time that I'm taking for the presentation that I'm deciding to just copy and paste my program just as it is. You can see the compiler has changed the color for my comments. As you can see, they are looking greenish. So this is the first section. You can see our prototypes are here. Our hash include is here using namespace, declaration for a global variable. Then we have our prototypes. This is the main function, as you can see. And then here are my definitions for my functions. So once you have been able to code your program, the next thing is to compile. You can compile the way you compile in your version, but if you are having the Visual Studio 2010, because as you can see, I'm using Microsoft Visual C++ 2010 Express. In this version, to compile, you click on Build, and then click on Build Solution. So let me click on Build Solution, and then we are going to see whether our program has errors. It has no errors. At the bottom of this screen, you can see and output something is happening. So you wait. You wait till the compilation is done. Now you can see that my compilation is complete. You can see 1 succeeded, a 0 failed. So our program is okay. And therefore, my dear students and the rest of the learners, if you copy our program just as it is, or just as you have seen this one, if you copy this program just as it is, when I say just as it is, it's because a programming language has a syntax, and I've coded this program in C++ obeying the syntax. So if you copy this program just as it is, just as I have coded it, and then you repeat the same, and you also duplicate or create yours, you realize that that program will not have any errors. So let's compile this program, and then we see what we are going to get. So this is the program that we have compiled. So let me run it. So to run it in Visual Studio 2010, you click on debug, and then click on start without debugging, because my program has no errors. But if it had errors and I want them to see where or which parts have errors, I would click on start debugging. Start debugging. Now, if you choose start debugging, then you'll be taken through step by step on the rectification process. But in my case, I'll click on start without debugging. When you click on start debugging without debugging, you can see that already our compiler has executed this first statement here. Input name, this function here for input name. So where are we? So the compiler has gone to our program, to the function for prompting for the name, this one here. So that is the first function which is being executed. This one. You can see enter name. So I'll type meme and then press enter. You can see my program has said welcome meme. And then it has already displayed another statement. Enter the radius of the circle. Which function is that? Let's see. So the call or the control has been taken to the next function or the next call statement. So this is where we are, and that is where this function is. Now, the function is called input radius. So let's go where that function has been defined and see how it looks. So this is our function. So the control has been taken there. You can see the first statement here is enter the radius of the circle and blink or take the cursor to the next line. That's exactly what you can see here. And then it is waiting for us now to enter the value of R, C in R. So I type, for example, 4. Then I press enter. Now, what has happened? You can see what we are getting next is area and the perimeter. Now, which function is this? This function is for displaying the results. It has only computed the area and the perimeter at the same time. So which functions are those? Let's see. We can see already it has computed perimeter. So this function for perimeter, this one here, find peri, has been executed and the result sent back to the main, and the value has been stored in memory location called perimeter. And then it has proceeded because it's the same radius. The value we have entered for radius has been passed the function called find the area. And you can see the work of function called find the area and find peri were purely for computing. There was nothing like displaying anything on the screen. So the value of radius you have entered has been brought here, and the area has been found, and the value of area has been returned to the function called main, and that value by the function called find area has been stored in memory function called area. And as you can see, the next function to be invoked is for displaying the results. So the function called result has been invoked. So that function is receiving area and perimeter, and here it is. So it simply means that this is now where our control is. It has already displayed the value of area and the value of perimeter in this order. You can see area equals, that's what we can see on the output statement here. Area equals 50.272. And then we have perimeter. Just as you can see this statement, look, perimeter equals, it has picked the value in memory location called perimeter and displayed. And the perimeter is 25.136. And the control has been taken back to the main function. So where are we? We are now here because we have displayed the results. If I press enter, what is going to happen? We expect this screen to close and the control be taken back to the operating system, and that means our program will be left displayed. So let me press enter. You can see That has brought our program to the end. And with that, my dear students and the rest of the learners, that's how we code the programs implementing functions in C++. That's how we implement C++ or functions in C++. And with that, my dear students and the rest of the learners, we have come to the end of part 8 of the series. You can now continue and listen to part 9, in which we are going to learn about arrays. Congratulations for learning part 8 in C++ computer programming series by the title Functions. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet again in part 9 of the series, and God bless.